postponed cardiac arrest. Get an X-ray. X-ray. Pulmonary here, we need thorax and thesis. So let's get things on here. Patient heart rate is speeding up. EKG is fine. Heart rate keep on speeding up. Any suggestions?
I'll just put let's try to say it good.
I think it's going. Ventricle defib. Clear. 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 Okay. Good afternoon, everybody.
You said good afternoon.
Good afternoon.
We need to have audience participation.
Good afternoon, everybody.
Good afternoon.
My name is Noel Hernandez. This is Vlademir. And Brian. Our group decided to do biomedical engineering. Pretty much. Today what we're going to cover, I'm going to give you guys a job description, responsibilities and duties, personal and educational requirements, credentialing requirements, discipline and relevant aspects to the relevant professional organizations, roles with other healthcare professionals, code of ethics and conduct, cultural issues, and pertinent aspects and issues. So the reason why we chose biomedical engineering, we felt that as though if it was the invisible hand of the hospital, as you could tell, it saves lives. So what is important? The various instruments that save lives every day, like the ECG or EKG, where we gave you a demonstration of the heart rate, and this is a Jarvik artificial heart, which is fairly new. And then later on, we're going to talk about some pertinent aspects afterwards. Okay, pretty much a job description. A biomedical engineer develops devices and procedures that solve medical and health-related problems by combining their knowledge of biology and medicine with engineering principles and practices. That is, biomedical engineers try to answer medical challenges by helping design and develop new equipment or methods. Let's name some. Anyone can tell me what this is? Yeah, but what kind of machine gives you pictures like that? You got CT scans and what else? MRIs. This is a three-dimensional ultrasounds that just came out like a year ago. You can see the video 3D and X-rays. Pretty much, the person has pulmonary edema. And this one right here, you can see a tumor in the brain. So pretty much, you could tell that these instruments, obviously, you can see that these help save lives in the hospital. So I think it's like an invisible hand that biomedical engineers play in the hospital. Next. Frequently, biomedical engineers supervise biomedical equipment maintenance technicians and investigate medical equipment failure and advise hospitals about purchasing and installing new equipment. Obviously, it's in their best interest. If their job is to alleviate, improve the quality of existing machines and improve quality of human life, making sure that the machines work, making sure that the purchase of the right machines work, and creating new research is definitely a part of the responsibilities, and creating new procedures. I'm going to introduce my colleague, Brandon, here, so he can give you the educational requirements.
Engineers into the occupational and bachelor's degree, the engineering specialty, research position required a graduate degree, college graduate degree in natural science or mathematics, and qualify for some engineering jobs. Requirements for undergraduate engineering schools include mathematics, science, English, humanities, and English. Engineering programs are designed to last 4 years, but students can take up to 4 to 5 years to complete their studies. Engineering technology schools usually offer 2 or 4 years degree programs that focus on the application of engineering principles engineers and biomedical engineering. The only difference is that engineering technology cannot be certified as for the field of biomedical engineering for a bachelor's degree. About 1,830 programs at colleges and universities offer bachelor's degrees in engineering and are accredited by the Accreditation Board of Engineering and Technology. It is based on programs, faculty, curriculum, and facilities. The license and certification, all 50 states provide licensure for engineers who offer their services to the public. Engineers who are licensed are called professional engineers, PE for short. This licensure is required a degree in accredited engineering program, 4 years of work experience, and successful completion of state examination. First, you must take 2 exams. The first exam is called the fundamental training. After engineers complete the fundamental training, they continue to take the engineers in practice of engineering principles exam. Once they take that, they are licensed to be an engineer. Next, I will present Brian Garced.
As you guys have heard so far, biomedical engineering has a lot of outlook, especially with the new technologies that are being developed and all the training and all the ideas that are coming up every day. There's new equipment. So, according to the Patient Outlook Handbook 2008, we expect to have a 21% employment growth over the projection of this test. That is one of the highest projections you can find out there. So in the next from 2006 to 2016, they expect a 21% growth. And especially we're going to see growth through the advancement in technologies. There's a lot of engineers now, who are in their 40s, 50s, who are about to retire as well. So we're going to get a lot more growth through them. We're also going to get, and especially now that a lot of the pharmaceutical companies are now taking over and becoming part of building new technologies, you're going to see a lot of them go up as well. So a lot of people transfer to management or sales occupations or leave biomedical engineering to go into nursing, to go into other fields as well. And in Miami, you can expect to, salary-wise, you can expect to make, somebody in the 50% with the benefits and everything. The average salary in Miami will be about 61 to 62,000. Nationwide, we're actually a little bit lower than the average because there's not a lot of companies. There's about 5 or 6 only here in Miami. So you can expect to make, on average, about 78,000, which is still really good compared to most people. And as far as roles with other healthcare workers, biomedical engineering is, like Noel said, it's the invisible hands behind it. We're everywhere. We're like the wall. You know it's there, but you don't really notice it throughout the day. And same thing, we have, we work hand in hand. We sit with pharmaceutical companies, and that was one of the big areas and we figure out what they need, and we try to develop new ideas or improve existing equipment. We sit with nurses to find out what we can do for them to improve. We sit down with cardiologists to find out what new stents we can design, if the material we're making them with is better or not. And we're also developing new technologies. One of the new hearing aids that's being developed is actually based on cell phone technology. They're roughly speaking, they're trying to take an iPhone headset, the earpiece, and they're even trying to use Bluetooth to develop new hearing aids. And we're also bringing a lot of technology based from computers. A lot of these new chips and particles, processors that are being come out, they're used for equipment, for the EKGs, for all of that as well. So now I'd like to pass it over to Vlademir.
In different countries, biomedical engineering is not recognized as a defined single profession, so it combines engineering and medicine. So in regards to ethics, in the last decade they've been developing what we call bioethics, but there's a discussion saying that bioethics should be the responsibility of everybody, not a single cluster of professionals like pharmacists or biomedical engineers. So ethics areas that would be related to biomedical engineering would be human genome project, like end-of-life issues, transplants, and research methodologies. So, if talking about ethical dilemmas, I would do a quiz, which is 3 questions. Who here thinks that we should allow parents to choose their baby's sex? Raise your hand, yes. Or no? Like half the class? Okay. Who say we should make people more intelligent? Say, should we be allowed to enhance cognitive function? Who say yes? Who says no? The rest of them, it's like about 20%. Last question. Who say we should get rid of genetic disease? Like, okay, 2. The real answer would be there's no answer because it depends on what the person, the professional thinks about it. They have the right to choose. This is now these kind of engineers they're not only involved with machines, so now they work with living matter. So that's what makes it so difficult to get the right answer in biomedical engineering. They take a lot of ethics classes to become biomedical engineering. That's why they've been implemented now. They have different kinds. They have fundamental ethics that's talking about meta-ethics. Meta-ethics talks about morality and different cultures. Normative descriptive ethics, normative ethics talks about the moralities and action, and divine command talks about God and a higher being, the belief in a higher being. They have research ethics, which talks about usually human and animal subject, how they should treat them. They have engineering ethics, where they talk about risk of analysis and negligence. They also have social ethics, talk about truth telling, euthanasia, whether they should, when people are in vegetative space and state, should they kill them or allow them to live longer? And they have social ethics that talk about legal ethics and legal development. Now, talking about the actual code of ethics of biomedical engineers, it's separated in different areas. The first area is their healthcare obligations. It says that biomedical engineers, they should enhance safety and healthcare and welfare of the public under the biomedical engineering profession. And then the second area talks about research obligations. They need to respect patient rights and confidentiality and privacy of their concern. Talking about professional obligations, they should be making a conscious effort to have cost-efficient procedures and make healthcare available for the general public. And then last, they have biomedical engineering research obligations, legal, ethical, institutional, governmental, and other applicable research. They should assume responsibilities towards colleagues and the subjects, like whether it's animal or human. And then when they publishing their work, they should be trustworthy, like say the truth and make it in simple language so everybody understands it. And when training others, because you see in every branch people have mentors and stuff, so they should be performing the research publishing results. They need to set the good examples for the younger ones.
So once again, we're talking about pertinent aspects and relevant issues to bioengineering. And I have a presentation that I wanted to show you. I believe the professors informed me of the date where I can give you the presentations on biotechnological issues of the future. Since we all are trying to become healthcare professionals for the reason that we're taking this class, we have to continue our education and learn not only the ethical aspects of, but also the dangers and other things according to that. GMOs, anyone knows what GMOs are? Yes, genetically modified organisms. Right now, one of the big ethical dilemmas they believe in is GMOs. And once again, in my presentation, I cover this, so maybe throughout the semester I'll be more in detail. But GMOs, pretty much what they do is they take the DNA of an organism, and pretty much what they do is they manipulate it in a way so that it can be safer, tastes better, has better nutrients, things like that. They have genetically modified rice. I think it's called golden rice. I'm not sure, but that's what it is. A lot of people have problems with this because you're affecting the food chain in nature, and this can have major effects. Next is the cloning human, and cloning a human everyone can already see that it has ethical dilemmas in it. Does a clone have rights? Pretty much people say that we should clone. So let's say you had an ailment and we made a clone of you, we could take the organ from that clone and we wouldn't have any histology complications to worry about. If you take an organ out of a clone, it's basically your DNA. So, but one of the questions in the cloning of human, does a human clone have rights? Does it have a soul and things like that? Eugenics movement, as Vlademir was saying, if we genetically modify certain things to make people more intelligent, is that necessarily good or bad? I don't know if you guys know comics, but Captain America kind of thing. S has to deal with a little bit about that, eugenics, and how they super soldier serum or whatever it is, they transform the DNA and to make these better soldiers, better basketball players, better people that are smarter, just intelligently enhancing people. Biological warfare is definitely a big aspect to it. Imagine if we could change the gene in any organisms. Imagine if we could make a terrorist organization takes HIV, which causes AIDS, genetically modifies it to just make it airborne or something like that instead of sexually transmitted or blood transmitted. All right. The nature of bioengineering is radically different. With only a modest $10,000 investment, one can conduct biotech experiments in one's living room and begin to manipulate the genome of plants and animals. With a few million, one can create a fledgling biotech industry. This is very, alarming. With only $10,000, you could dollar investment, you could actually start manipulating the genes. Francis Collins says, I'm not such a Pollyanna as to imagine that information this powerful cannot, in some future instance, be used in the wrong way. If you believe that one of the strongest mandates of humankind is to pursue ways to alleviate human suffering, you really can't be against this research. But it's knowledge. It's not good or bad, it's just knowledge. It's all knowledge. The cliche of knowledge is power is so true. And according to the ethical issues that are coming up, maybe some of us should switch our majors to law or something so we can make more money off of that. Any guys have questions?
Any questions?
Well, I'll be sending you guys the pamphlet, the sheets through email. I'll email you guys the sheets. Thank you very much.
Yes, we missed that sheet. So we need a sheet before, so we can follow along.
Okay.
Right? As you distribute it before you start presenting. Next presenters, remember that you do that, so we can follow along. Humanities. Mr. Hernandez, you all don't go to see yet. I have a question.
Okay.
Which I just heard you. You mentioned that humanities was reading, but humanities is one of the subjects that classes that you take, right? And a lot of students in the medical field shy away from humanities and say, why am I doing humanities? Can you shed some light? Anyone can answer, any other panel can answer this. Can you shed some light as to why humanities would be a good course to take? Anyone of you can answer.
Well, we gotta be pretty much, if we take humanities, we gotta, in the medical profession, we gotta be aware of a lot of things, just not only in our profession, but in other professions. And therefore, when you take humanities, not only are you taking it with other people that are gonna be healthcare professionals, but other professionals. Now, taking humanities, when you're taking humanities, you're learning different aspects of a variety of different aspects from different fields. Therefore, you get it.
C word. I need to hear the C word.
C word. Oh yeah, well, that's what I was going to get into.
Yes.
You learn also cultural aspects, as I was going to get into. You're learning also cultural aspects. Big major thing about how we're doing it today in our chapter, I believe 15. We're talking about culture and how we have to respect one's culture and tailor your care to that person's culture. You know, some things they might find offensive. I know in Australia, you know, thumbs up is the F word over there. So you got to be very careful on how you do things. In some cultures, you cannot look at them straight in the eye. You have to look down. It's you know, some people are overt or exert. You know, they're very, you know, there's very different cultures, and therefore you have to tailor your care. Let's say a patient who practices Hinduism. As a nurse, my major is nursing. Therefore, these people that practice Hinduism, they're vegetarians, they're vegans. Therefore, when I tailor if I make a diet plan for them, I have to tailor that plan so that it fits that they only eat, you know, vegetarian things. I can't add meat. If they need protein, then I have to supplement them with a pill or something else other than meat. You know what I'm saying? So therefore, you have to be very aware, and Humanities provides that for you. That's why you need those different classes.
The Humanities gives you a bit of the background of different cultures, their history. I mean, for Judeo-Christians, the Bible means something to them. But if you don't study Humanities, you won't know that there is a book that means something to another culture. So it's a good background course to warm you up towards being appreciative of other cultures and other eras also. Okay, I like that Brian mentioned when he did the salaries, he brought it right down to Florida. I want that, I expect that, because remember, we're trying to keep this class real. We don't want you to just come in, do little bubble sheets, and then you'll pass the class and you haven't taken away anything with you from this class. So keep it real. When he's telling you what a biomedical engineer could get in Miami, it makes more sense to you than if he's just giving you a national figure. You can feel it, touch it, it's real. So try to keep your presentations real. I like the fact that they got into the ethical issues, and we all know about the slippery slope of ethics, and so congrats, good presentation. I said that you all should, and I see your taping, your movie. I said you're performing, doing a performance and movie. Yeah, it was an excellent presentation. A lot of work.